So last time we saw the Friedman equations, and this time we are going to see a very important parameter which we call a scalar factor. And from scalar factor we can derive expression for Hubble parameter or Hubble constant. So we denote scalar factor by A. A is the denotation for scalar factor. So what is scalar factor? So for deriving a scalar factor, for knowing a scalar factor, we have to um, make a coordinate system. Make a coordinate system. This is our coordinate system. Uh, this is a coordinate system. So we have to make a coordinate system such that the galaxies are some sort of fixed in the grids of this coordinate system. These are the galaxies. So these are fixed in this coordinate system. The coordinate system is three dimension. We take x axis, y axis, and z axis. I am making this a 2D for my ease. So these are the galaxies. These are the galaxies. So the coordinate system is make such that it expand or contract with the galaxies. If the universe expand, the coordinate system also expand. If the universe contract, the coordinate system also contracts. So this is make such like this. These galaxies are always fixed, are always freeze in this coordinate system. So what if we want to know a distance between two galaxies? Like if we take this as galaxy A, this as galaxy B, and the distance between them is delta x, and we want to know the distance such that at any instant of time we can get its position and a flexible distance, because the universe is expanding, because the universe is expanding. So the distance between A and B will increase or decrease as if it is contracting, it is going to deep freeze. So the distance delta x must be a variable. So what we do is we define a distance d AB between the distance between AB is equal to A, which is function of time, A of t times delta x. So this A we call scalar factor. Scalar factor. This A we call a scalar factor, and this and delta x is the coordinate distance between them. Coordinate distance between them. So, and this DAB is the distance between the galaxies, which we are going to find out. So if we generalize like this is our galaxy 1 and this is our galaxy 2, and we have to know the distance between them. So what will be the distance? This distance we will give as, we take it as P, and we take this as Q. So the distance P and Q is equal to a scalar factor times scalar factor, which is time dependent, which depends on time. It may be a constant or it may not be a constant. It depends whether the universe is expanding or is stationary or contracting. So it all depends on that. And this dpq is equal to at times under root of delta x square plus delta y square plus delta z square, depend on the coordinate system. So this is how we see important parameter, which is scalar factor. Scalar factor. We will further see how it is helpful in cosmology for us.